This is part 2 of section 6.4. We're going to talk about adding and subtracting vectors geometrically. So if we have a vector v right here, and this is the initial point, and we have a vector w here with right now an initial point here and terminal point here, we can move. We know from here that that the vectors don't have to be in a particular position. The only thing that's important is the length of them and the direction that they go. So to add vectors, you take if I do v plus w, I go from the initial point of v to here, and then I take the w and I orient it so that the initial point is at the terminal point of v, and do that. Your answer is the vector from the initial point of v to the terminal point of w. Okay, and this just sort of explains all of that again. So anytime we're going to add vectors, your answer is going to be from the initial point of the first thing listed. You locate the other thing you want to add at the terminal point. You just sort of build them onto each other in this right here. Now this answer is called the resultant vector, and this term comes back later. Okay, so let's look at an example here. All right, so here I have a picture, and this is similar to what we had before. If I have w plus v, then I have the initial point of w here, and I place the vector v at the terminal point, and I go to here, which gives me this vector. This would be w plus v. Whereas if I do v plus w, I go up first and then over, and I end up with the same resultant vector. So this tells me that vector addition is commutative. Now, that was not a given. Scalar addition is commutative. We can switch back and forth, and we knew that. We've known that for a long time. But vector addition is defined differently, and so we needed to see that this is possible. So it does not matter when you are adding which order you add in, okay? So, and you can see that, it does create a parallelogram and that this vector is the diagonal, okay? Now, vector subtraction is defined in much the same way, okay, as in real numbers. For any two vectors, v and w, v minus w is the same thing as v plus negative w, where negative w is the opposite of w. Okay, so if I have, here's my vector v and here's my vector w, and I want to do v minus w, well, negative w is going to be the same length as w, but pointing the opposite direction. So what they've done here in this image is they sort of doubled this over here. And then just like here, we would take v, and then we would place the negative w at the terminal point. And then v minus w will be from the initial point of v to the terminal point of negative w. Okay? But, this can get a little cumbersome, and there's an easier way to do it. Okay? We don't necessarily have to draw the negative w here. What we can do instead, and you can look and compare the image here, we're going from here to here, that length. This picture has the same length and the same direction, but they did it without drawing the negative w. So what you do when you are subtracting is you place your two vectors so that they share an initial point. When you're adding, you put the second one at the terminal point of the first. But when you're subtracting, they share an initial point. And then v minus w is the vector from the terminal point of w to the terminal point of v. So you're going to connect these two, and the arrow is going to point towards that, the first one. Okay? So that's the geometric version of vector addition and vector subtraction. Now we're going to throw in some scalar values. If v is a vector and c is a scalar, or just a real number, the vector CV is called the scalar multiple of V. And we have this image below here. So if this is my vector V, if your scalar value is larger than 0, then your vector has the same direction as V, which is what we have here and here, the same direction. And the magnitude is multiplied by that scalar. So here was V. 2V would be twice as long. Half V would be half as long, but they're pointing in the same direction. If your scalar value is negative, it's going to have the opposite direction. So here I have 2V. Negative 2B has the same length, but points in the opposite direction. Okay? And if your scalar value is 0, then C times V gives you the vector 0. Okay? So scalar multiplication still gives a vector answer. All right? So let's use these vectors right here to calculate these. And these are just basic grids. They're not located in any particular place. So that's why there's no axes or anything. I just want to get this thing drawn. Okay? So if I do U plus V, first thing I'm going to do is I'm going to draw U. So that would be, use a different color here. U is vertical pointing down and it's 2 units long. So that is U. All right. Now I'm going to draw in V. And V is 1 unit with a slope of 1. That's how I think of it, of 1 over 1, pointing in the upper right. And since I'm adding, I'm going to place it here. I'm going to line up the initial point. And it goes to here. And that is V. That's our vector V. And this is our vector U. So the answer vector, U plus V, our resultant, starts here, points here, and that is U plus V. Okay? Now, 3V. So I'm going to take vector V, which has a slope of 1, and I'm going to make it 3 times as long. So V goes up 1 unit. So 3V will go up 3 units. And that will be our vector 3V. Okay, so now let's look. I've repeated this over here. We have the same vectors, just different sheets, so I thought I'd make sure it was repeated. 2U minus W. So the first thing I want to do is I want to draw 2U. So that's going to be, let's just place it here. I don't know, start it here. It goes down 2 normally, so I'm going to bring it down 4. Because it's got to be twice as long. 1, 2, 3, 4. So that is my 2U. Now I want to subtract W. And if I'm subtracting W, that means I'm going to make sure my initial points line up, and I'm going to draw in W. Okay. 2U minus W will connect these 2 points. And it will point in this direction. Okay? It points to the terminal point of the first thing you're doing. Okay? Now let's do U plus V plus W. Okay, so let's draw in U first. So U is 2 down. So that is my vector U. Now all of these are addition, so we line up initial points with terminal points. So V goes 1 unit up, and I place it here, and I go up, so that's V. Okay, and then from here, I need to draw in W, which goes down here. Okay, so what is your answer? This is where you started. After all your forces acted on everything, you end up with this.